Hello all. In this video, I'll make two exercises to explain the resistor and to apply some rules, the Ohm's law and the rules for the equivalent resistance grouping of resistors in series and parallel. The first exercise, let's read it together. An electric circuit is connected up as shown in the adjacent document. The battery supplies a constant voltage, GPN equals to 12 volts. Usually we write the given on the drawing. The two resistors R1 and R2 have resistances 10 ohms and this is 15 ohms respectively. Lamp L acts as a resistor of resistance RL equals 10 ohms, so we can consider it as a pure resistor and bears the inscription 4.5 volts. The voltage across R2 and L is the same. Why? Since they are connected in parallel, so according to the law of uniqueness of voltages in parallel, so U of the lamp, the voltage of the lamp, is equal to the voltage of R2. Okay, so show that the equivalent resistance R2 and L, these two resistors, we considered L as a resistor. R prime is equal to 6 ohms. So in the question, he denoted the equivalent resistance of these two resistors as R prime. So we cannot call it R equivalent. So since these two are parallel, so we say that 1 over R prime is equal to 1 over R2 plus 1 over RL, the resistance of the lamp, equals to 1 over R2 is 15 ohms and the resistance of the lamp is RL equals to 10 ohms. Using the calculator, let's try it together. 1 over 15 plus 1 over 10. Okay, 1 over, let's open the bracket. 1 over divided by 15, close the bracket, plus, open bracket, 1 divided by 10, close the bracket, equals, okay, so it's 0.167, so this is equal to 0.167. We need the R prime and not 1 over R prime, so we'll just make the reciprocal. This is the reciprocal, it's 5.988, so it's okay, so R prime equals to 6 ohms. Okay, 6 ohms. I'll just copy this unit, 6 ohms. Okay, now deduce the equivalent resistance RE between A and B. A and B, this means that we need to calculate the total equivalent resistance of the circuit. So these two resistors, the equivalent of these two is called R prime. R prime, so we can calculate it. They are connected in series, R1 and R prime. So simply we say R equivalent is equal to R1 plus R prime, plus R prime, which is equal to R1 is 10 and R prime is 6. This is equal to 16 ohms. Okay. Okay, we should write here connected in series, and in this we should write connected in parallel. I always forget this. Connected in parallel or parallel connections. Okay. Okay. So now by applying Ohm's law, calculate the main current I in the circuit. Applying Ohm's, let's state Ohm's law. U equals to RI. In parentheses, Ohm's law. Okay, substituting calculate the current, we say that I equals to U over I. So U over I. Yes, which is equal to the voltage of the total circuit, the UPN, the voltage of the generator, is given as 12 volts. And the resistance actually it's the equivalent resistance. So instead of R, we should write R equivalent. Okay, so R equivalent times the main current. So we also denoted by UPN. So UPN is equal to R equivalent times the main current. So R equivalent, we calculated as 16 ohms. So 12 over 16, let's try. 12 divided by 16 is equal to 0.70 equals 0.75. The SI unit of current is amperes. Determine UCB. UCB is the voltage between the terminals of R2 and L, or R prime, you can say. So R prime, the main current passes through R. So we simply we apply Ohm's law. U equals R times I. But we should always specify which voltage and which resistance and which current we are using. So the voltage determined UCB, so it's of course UCB. Okay. Now R. What's the resistance between C and B? Between C and B we have R prime, which is the equivalent resistance of these two resistors. So instead of R, I will write R prime. And I, the current passing through R prime is actually the main current. If we drew another circuit, putting R1 and R prime, the main current is passing through R prime. So it is I. And between parentheses also Ohm's law. Okay. Just substitute the numbers. R prime, we calculate it 6 times the main current is 0.75 times 6 equals to 4.5, sorry, equals 4.5 volts. The lamp L functions normally. How can we know whether the lamp functions normally or not? We just compare with its rated voltage. We can see here that it bears an inscription of 4.5 volts. This means that its rated voltage is 4.5 volts. So we say that the voltage of the lamp is equal to the rated voltage U rated, which is equal to 4.5 volts. So the lamp functions normally. Okay. We can also write it not mathematically. We can say the voltage of the lamp is equal to the rated voltage, but I wrote it like this for simplicity. Now we replace R1 by connecting wire of negligible resistance. Instead of R1, we have a wire. Okay. Give the value of UAC. Between A and C now is a wire. So UAC is equal to 0 volts. If we need the justification, you can say UAC is equal to U wire, or you can say it's equal to the voltage of the wire, which is 0 volts. Determine UCB. Now UCB is equal to the voltage of the battery. Okay, so UPN equals to UCB equals to given 12 volts. Why? According to the law of uniqueness of voltage in parallel. Okay. Now show that the lamp may burn out. The lamp now receives UCB, so it receives 12 volts. Its rated voltage is 4.5 volts, so of course it will burn out. So since U lamp which is equals to UCB equals 12 volts, greater than the rated voltage, which is 4.5 volts, so the lamp will burn out. Okay, I'll leave the second exercise for another video since I reached 9 minutes. I'm sorry. Thank you, and see you in the next part. Bye bye.